Now we have to understand the concept of raster modification. See, raster band modification is nothing but adding or removing some bands, right? So for that purpose, we will use some simple set of codes which is very easy in R. So what we can do, see, this is the stack. I'm going to create the stack again. Say I'm creating the raster stack and say I want to drop any one band. So what I have to write, I have to use one variable, and for dropping layer from the stack, I have to write drop layer, and see this L is in capital letter. Drop layer means this drop layer function is used to remove one particular band from the stack. So here whatever raster stack I have created, it is stored in the variable rasters. So from this rasters, I want to drop band number 6. So that's why I have written drop layer raster comma then 6. And now using names function, if you write names and then if you write this variable name, you will be able to check whether a particular raster is dropped or not. And if you see the output here, we have band 1, band 2, band 3, band 4 and band 5. Band 6 is already dropped. But you have to remember one point, which is a very important point. Index value of R starts from 1. Means whenever we are learning any programming language, say we are working on C programming language and say we are dealing with some array, say it will start from index value 0. However, you have to remember one point, in our programming language, the index starts from 1. So why this concept is important? See here. So now this is how we can drop a band from a particular stack. But it may happen that we want to drop more than one band simultaneously. So at this point of time, we will use the same function drop layer, but here the syntax will be this. Now we have to understand what is the meaning of C2, 5. Say in a stack we have band 1, band 2, band 3, band 4, band 5. Now it is stored in index 1, it is stored in index 2, index 3, index 4, index 5. Now if I want to remove more than one band from a stack, say I want to remove this band and this band. So what I have to write, I have to mention the index values. So I want to remove band 2 and band 5. So their index values are 2, 5. And now all these bands, they are treated as vectors, just like an array. So for that purpose, we have to write a C function. C function means the combine function that will use to combine the indices. So I'm going to drop band 2 and band 5. So the thing is, you have to mention the indices number. Since we have more than one indices over here, therefore you have to use the combine function. It means it will drop band from index number 2 and index number 5. And before that, the function name will be same, drop layer. And here what you have to write, here you have to write the variable name in which you have created the stack. So that's why I have written it as rasters. Raster means this is the variable in which the stack was created. And then C2, 5 means position number 2, index number 2 and index number 5. These two bands I want to remove, I want to drop. So if I write names and the variable name rasters D2 where I have dropped the two bands, then if I display it, see band number 2 and band number 5, it is not there in the list, right? They are dropped. So we can remove one band at a time, or we can simultaneously remove more than one band. So this is a part of raster band modification. Similarly, we can add some bands. That is, If some bands are already loaded in the stack and I want to add one more band in the same stack, so I will use a function add layer. This add layer function is used to add the band. Say I want to add band 2 in the same raster variable, means in the same variable or object where I have dropped previous two, and here I want to add one. So I will execute this one in order to add a particular band. So here see, I have got one error. So can anyone tell why I have got this error over here in adding raster band? Actually, here there is one important point. See, whenever I have created the raster stack, I have clearly mentioned that modification of bands are only possible when they are loaded properly. But see, unfortunately, by mistake, I forget to load band 2. Here, whenever I was performing band modification, the band should be there, then only I can add or remove it. And also, I have already removed band 2. See here, and unfortunately, even if it is loaded, I have already removed band 2 over here. So here band 2 is removed. So for that reason, it is showing us some error. That is, this band is not there. So while deleting the bands, you have to be very careful which bands you are deleting and which bands you are adding, right? So just now I have deleted band 2 and I'm trying to add this one. So what I have to do, again I have to load it and then only I can add band 2. So this is how we can add or modify different bands from the raster stack and into the raster stack. But which one is more important? See, now we are talking about a very small project. Means why this band modifications are important. Now first I will show you some of the properties. Then you will be able to understand. So here what I am doing, I am just loading bands again because some of the bands are deleted, some of the bands are added. So without going into the confusion, I'm just loading all the bands one by one. So whatever bands I have downloaded from Landsat 8, I'm just loading all the bands. Now I will show you one beautiful application. So band 1 to band 6, they are loaded. Now I will talk about a new concept which is known as false color composite. Now what is this false color composite? I'm just giving you a very brief idea, then you will be able to understand. See, the concept of false color composite is a color rendering method. So whenever I will discuss about false color composite, what is the utility of this mechanism, I will tell you later on. But in the simplest way, we can say that this mechanism is a rendering method. Rendering method means this method is used to display remote sensing data. So whenever you are going to display some remote sensing data, then you have to use this rendering method which is known as false color composite. See, I have fetched the data from Landsats, means all bands are taken from the source Landsat, right? They are collected in a particular region or zone, you can say. We are talking about Vietnam. And they are collected in a region beyond the visible spectrum. So for that purpose, we use different band combinations, say band 1 to band 6, to render them on screen. So whatever raster we have downloaded, they are beyond the visible spectrum. That's why we have explored band 1 to band 6. The main reason for exploring band 1 to band 6, all these combinations, in order to see them on screen, means this is used for the clarification purpose. Now what I am doing, let's see over here. So let's apply the code first. So for false color composite, what I am doing, I am just using a plotting mechanism. Plot RGB. First thing you have to understand, whenever you are applying false color composite, make sure that whatever bands you are using, all must be loaded freshly, and then only you can apply this mechanism. So in this case, what I am doing, I am going to plot something. So what I am going to plot, let me execute the code first, then check what will happen. See, whenever I'm just writing plot RGB, then it is showing some charcoal kind of image. So what is this? So in this case, the purpose of the false color plotting is we are trying to render the optical color in RGB format. So in this case, red, that is R, red band is the band 3. That's why I have written R equal to 3. Green band is band 2 and blue band is band 1. And here I have used histogram stretch. It's a function name. It's a plotting mechanism name, histogram stretch, and it is applied over here. So what is the output? See, if you visualize this output will not tell you much. So here the thing is why we are using false color composite, in order to visualize all the bands together so that we could fetch some meaningful insight from this plots. So here if I use this plot RGB where R equal to 3, G equal to 2, B equal to 1 with histogram stretch, what will happen? Whatever output we are getting from this output, it is very hard to decode whatever we are perceiving. So some portions are black in this plot and some portions are very pale, and we have got some yellow red kind of thing at the bottom of this image. So there is no sign of green vegetation. Basically we are going to explore what kind of green vegetation we are having. But with this kind of plot, I have no idea what kind of vegetation or where the vegetation should exist. So what I will do, I will use the same code, but here I will just change the histogram stretch to linear stretch. Now see what will happen. In place of histogram, HIST, I am just replacing it by LIN, and then I am going to execute this one and see what is the output. So now we can see that the areas which have presumably green vegetation look greener and sharper, and most degraded areas or areas with possible human habitation, they look paler, or you can say that they look browner. So the browner shades, we can say that they have human vegetation, and where we have the green and sharper image, we have green vegetations over here, and we have some kind of less number of vegetation that is a pale green in color. So it is quite good. However, when we render the vegetation data, we render in such a way that vegetation data will be visible in the red color. Now I want to highlight only the vegetations. So in the false color composite, it is a convention that we will highlight those vegetation in the red color. So what we can do, we will use the same code. Now I will change these values. R equal to 4, G equal to 2 and B equal to 1. Means here at this point of time we end up rendering the vegetation data. So the near infrared band means the band 4 in this case. I have assigned this band 4, that is in R. So the near infrared red band, that is band 4, is now assigned to the red component, and red band is assigned to the G component. The red band was band 2 and was assigned to the G component. You can see the code over here. And we have B is equal to 1 over here. That is the band 2 is assigned to the component B. So there are other band combinations that are available to bring out this concepts from the data. But here we are trying to find out the conceptual implementation. So after changing the assignment C, what kind of output we can expect? See, my intention was marking the green vegetation. So what I have done, I have changed this green vegetation into the color red. So whatever red color we are having, we can clearly state that these are the portions where we have the vegetation marked. So we can easily say that, say this is the raster, and this raster has the combination of 6 bands, and the red portion that we have marked right now are the vegetation portion. And also if you see this plotting, see if you have the dark red color, it means we have more vegetation at that point of place, and rest of the places whatever other color we are having, they are human habitats, means there we have human habitats and other things. So this is how after fetching a particular raster, we can manipulate all the bands one by one, and then we can extract information whatever we need, whether it's a vegetation or any other information from that particular raster. So this is how you can work with the spatial data. And that's why the concept of false color composites are used everywhere for all kinds of project. Because whatever you are trying to find, all those things can be marked using false color composite. So this is the main concept. And see what is the recent trend over here. So if you are using R programming language, you can do easily this kinds of coding. And whatever plots you are getting, they are very much easier to visualize, right? So now let's talk about a very small project. Say if you are doing a project where you are going to identify the rock characteristics which are near to some riverside. So what you can do? So you can extract data from Landsat, you can extract data from Sentinel, you can extract data from Rapid-Eye. Lots more sources are there. And after extracting data, means data is coming in the format of raster. Now what you can do, you can analyze the bands, means how many bands are there in each source and which band is depicting what. Say you are fetching 3 bands from Landsat, you are fetching 2 bands for Sentinel, and you are combining all those bands, right? It is possible. Because if you are combining the bands together for your project, it will give you more information. But while combining bands from different sources, though they will give you more information, but you have to keep in mind all bands are coming from different sources. So what you have to do? You have to perform 3 things. First, you have to decide in which coordinate system you want to work. Now you have to change any of the band format into that coordinate system. Now, if all the bands which are collected from different data sources, they are in the same coordinate system, same extent, same resolution, then only you can combine them in a stack. After creating the stack, if you feel that you need more bands, so you can add the bands. And after stacking, if you feel that some bands are not useful, you can delete those bands. But after stacking, what you can do? Now you can create stack using stacking mechanism or breaking mechanism. Then it's time to mark the rocks which are near to the river. So at that point of time, you can use false color composite and you can mark the rocks with the red color. So then it will be easier for you to visualize which portion are the rocky portion which are near to the river. So this is how you can identify object in a spatial data. So this is the concept, and it's a very interesting thing. And for a very small project, you can start downloading bands from different sources. But one thing I want to explain, say you are downloading some bands from some data source. So if they are not in TIF format, If they are in img format, then you can convert it, or if they are in .rst format, then you can also convert it in TIF using R. But there is one alternative. See, this is known as Snap tool. You can download this tool for your desktop. Now, this Snap tool is very much important in order to convert any kind of image into TIF. Just you have to use one or two click and then you can convert it into TIF. So if you don't want to write code in R in order to convert anything in TIF, you can use Snap tool. So you can convert any band collected from any image source, Sentinel, Landsat, by Snap tool. Right. So this is another way of converting image.